Okay, thank you so much, VK. Really appreciate the warm introduction and the collaboration that's moved this webinar series forward. I'd like to share my screen, and can I confirm that my screen is now showing on the webinar? Can everybody see that okay?
Yes, we can see it here.
Wonderful. Okay, so yeah, I'm going to do a bit of a framing presentation, and VK did a nice job of introducing some of the main content. And the sort of essential claim that I'll make here is that it's really important, of course, for us to do a better job of assessing how air, climate, health issues come together in different policymaking processes, and identifying solutions that can maximize the synergies between these issues. At the same time, I'm also going to talk a lot about not only strengthening the integration between those issues, but also strengthening the interface between science, policy, and action, and how this theme of what we'll call feasibility features in strengthening that interface. So without further ado, let me move forward. And the first thing I would like to highlight here is this idea of co-benefits. So for those of you who have participated in this series of webinars, you've heard this term over and over again. And I mean, the work that I do here at IGES is, focused a lot on the co-benefits or the multiple benefits of actions that are good for climate change, air quality, health, and a bunch of other development concerns. And this term actually has been, used in academic circles for going back approximately 25 years or a little bit more than 25 years. But as we can see from this slide, there's been a tremendous surge in the research on the term. And a lot of it focused on co-benefits, especially in China. But we can see, over the past 5 years or so that there's now approximately 18,000 articles that have been published on that include some aspect of co-benefits. And the co-benefits that often feature here are looking at air pollution, climate change, and health. And I think, along with the advent of the Sustainable Development Goals, the SDGs in 2015, and the Paris Agreement, which also puts a very strong emphasis on integration, we're seeing, more and more reflection on the interrelationship between many different issues. So air pollution, health, of course, and climate change. But just to give you another flavor, I mean, also water insecurity. So I think my colleague Charlotta from IASS, she'll talk a little bit about something called black carbon and short-lived climate pollutants. And so one of the things we also see with some forms of air pollution is that it gets deposited on glaciers and snowy areas, causing accelerated melting. I mean, this is particularly problematic in Asia and the Himalayas. And this can lead to changes in water patterns and lead to other struggles for, of course, for crops and flood control, what have you. So we're seeing more and more of a sort of not just a co-benefits approach, but a nexus approach, where there's a lot of interlinkages between these issues and a growing amount of science that's trying to understand how they relate to each other. So hence the name Air, Climate, and Health Nexus. We're also seeing more and more that these issues do not only relate to each other, but they also transcend physical boundaries. So let me give you a very personal example. I grew up in the city of Boston, Massachusetts, which is on the east coast of the United States. And what I noticed in 2021, I mean, I'm based in Japan, so I didn't actually experience this, but saw it on the news, is that over the Charles River, which is the main river which bisects the city of Boston and separates it from Cambridge, you get images like this. And when I was growing up, we never saw air pollution like this in Boston, or at least in my recollection, I don't remember seeing this type of smoggy air pollution. Well, the question, of course, is where is this coming from? Well, this was coming from the wildfires in California, which is about 5,000 kilometers away. This just goes to show that, one other way that the climate change is leading to air pollution that's expanding over different boundaries. And I think, for instance, one of our colleagues during the panel discussion, Sang-Min Nam, will talk a little bit about some of the impacts across different boundaries. So this nexus not only has, this sort of physical interlinkages, but also going across different boundaries is another way that we're looking more and more at this nexus, and also leading us to think more and more about why we might need an approach that deals with the atmosphere as, a system, a one atmosphere approach, if you will. Okay, now this leads me to sort of the next point that I would like to raise, is that the more that we think about this nexus and the more we think about this sort of one atmosphere approach, it's not only important to have a stronger scientific understanding and good modeling that demonstrates what might be some potential solutions out there, but we also need to be able to translate those solutions and that modeling into policies and actions. And I would suggest to you that, we're at a place right now where we're moving across this bridge sort of gingerly and one step at a time, but definitely making some progress. But the magnitude of the problem and the size of the opportunity suggests that we need to move a little bit faster. And so what I'd like to share with you now is some of the research that we've been doing, that VK also mentioned, that will help us, translate some of this research into solutions that inform policy and action. And this leads me to this report that we're working on with colleagues at IASA in Vienna. It was also introduced in an earlier webinar, as well as colleagues from Stockholm Environment Institute. The report's title is Clean Air Solutions in Southeast Asia, and should be out in May or perhaps June of this year. And basically, this report identifies a series of different technological and social changes that could lead to significant improvements in air quality, with also some positive knock-on effects for short-term and long-term climate change, as well as health, crop yields, and some other sustainable development goals. And what I would like to highlight here is, okay, so these solutions have significant potential to deliver many of these benefits, working across the air pollution, climate change, and health nexus. But in order to actually implement these solutions, to come across that bridge, we need to think more and more about what it takes for successful implementation. And this is going to be particularly important for things like, just highlighted two of the solutions here that have strong links to behavioral changes. One is this vehicle inspection and maintenance programs. These are programs basically that help to ensure that the vehicles that are operating without repair, sometimes called super emitting vehicles, that they do get repaired or get replaced. And this can be quite challenging because, of course, it requires not only inspection and maintenance, but a lot of times the operators of these vehicles don't have the resources to necessarily invest in repairs or in a new vehicle. So there's strong relationships with development issues here as well. Another solution that I want to reflect upon, which I'll come back to at the end as well, is called this agricultural residue burning, and basically, how we can promote different solutions to curbing the burning of rice stalks and field residue. And this happens a lot of times, especially because farmers want to clear the field for another planting season, and also has strong linkages to behavioral changes and development issues. So these are two significant solutions that need to be implemented effectively to realize their potential. And there are some ways that we can look at increasing the feasibility of their implementation. So one of the ways that's typically done, and I mean, if you read our report that I just mentioned, is of course careful case studies. And just to give you an example of inspection and maintenance case study. So for instance, in Thailand, the Bangkok Mass Transit Authority has been quite successful in implementing vehicle inspection and maintenance programs for the buses it's managing. And so we can learn some lessons from this type of case study, and I think that's extremely important. And we need to provide those types of success stories to inspire action on the ground. So that's good, and I think we need to keep on doing more of that. And in fact, our Asian Co-Benefits Partnership, which is a network that we oversee or serve as a secretariat for, has many different case studies on successful implementation of co-benefit solutions. But what I would like to see us do more of, especially from a social science perspective, is to think a little bit about how we can bring this concept of feasibility into some of our modeling work. And this is already happening to some extent. You can see what is called a feasibility framework in the climate change, the IPCC 1.5 degree report. We'll also see this in the 6th assessment report. And what these feasibility framework does is it takes a different sets of solutions. So for instance, you can see here for energy transitions or renewable energy, and it rates them in terms of their feasibility across different types of dimensions. So there's an economic dimension, a technological dimension, an institutional dimension, a social dimension, an environmental dimension, and a geophysical dimension. And this assessment, the rating, is done, at least in this context, based upon a literature review to see across a series of different cases and different analyses, whether or not it's feasible to clear economic barriers, technological barriers, institutional barriers, and what have you. And so I think this is an important step forward. And this is also making some links to, some of the modeling work that informs, our IPCC report. So I think that's a great step forward and something we should be thinking about when it comes to co-benefit solutions too. We also see another approach to looking at feasibility, which is actually looking at the feasibility of entire scenarios. And this is coming from recent work that has been published last year in environmental research letters. And what the authors did in this case is they looked at different dimensions of feasibility again, so technological, economic, sociocultural, institutional, and then sort of an overall rating for the scenarios that were in the 1.5 degree report. And what they showed, and what I'm demonstrating here from this diagram, is that in terms of the institutional feasibility, some of the governance and policy issues, there are still significant concerns whether or not implementing the 1.5 degree report scenarios are feasible, whether or not there's enough capacity within government agencies to actually implement some of these scenarios. And that's why this little bump up here, this distribution, is higher than the other dimensions of feasibility. The other thing that's notable here too is when it comes to some of the sociocultural issues, the feasibility seems to be relatively high, but the actual assessment of this feasibility, there's limited amount of data and information for some of the scenarios. So out of the 76 scenarios that they evaluated, they were only able to get information for 64 of the 76 scenarios when it came to the sociocultural dimension. So the feasibility issue is important, and the institutional and some of the policy issues are extremely important. And this gets us to some of the work that we're doing here at IGES that's helping to try to move forward and help bridge some of this gap between the sort of science and policy and action, so that we can actually realize some of the benefits from an air, climate, and health nexus. So this is looking at a feasibility framework for some of the transport solutions in Southeast Asia. And so what we did is we did, similar to the previous feasibility framework, we did a literature review on inspection and maintenance programs, on stronger emission standards, on switching to electric vehicles. And as you can see, especially when it comes to the inspection and maintenance programs, the darker the color, the more significant the barrier, or the more significant the feasibility challenge. The social institutional issues are quite significant. And so these are something we need to look at more carefully and see whether or not, how we can overcome them. and also think about how do we bring them back into our modeling frameworks to understand what would happen if we don't overcome these barriers. And this will also, I think, inform some of the policy and institutional changes we needed to actually move forward with some of these solutions. So the next step we're taking now is doing expert elicitation, or basically surveys with government officials and experts that are familiar with some of these solutions. And we're working with colleagues at the AIT, Asian Institute of Technology, to do this, as well as the Pollution Control Department in Thailand, to do this for instance, inspection and maintenance programs, as well as for open burning. And so what we've done is we sent out the survey to understand to what extent some of these solutions are feasible, and to what extent some of the dimensions I mentioned before might cause challenges for implementing some of the solutions. And based upon that survey, then we're able to quantify, at least roughly quantify, to what extent some of these challenges might impose or make some of the policies ineffective. You can see here, this is for the open burning and inspection and maintenance. This is the early results of some of our survey work. And what you would assume is if there were no barriers, if there were no challenges, if everything was perfectly feasible, that these bars would basically be very, very short or not there at all. So 0% is sort of desirable here. That would be effective implementation. But what we're showing, as you can see, is when it comes to inspection and maintenance, some of the challenges, some of the barriers there are making the policy and the diffusion of technologies, or slowing the diffusion of technologies by 60 to 70%. And in the case of inspection and maintenance, once again, the institutional and policy challenges are the most significant. And when it comes to open burning, similarly, it's between 50 and 60% that we see some challenges there. In this case, the economic challenges are the greatest, but the institutional and policy challenges are the second greatest. And we also are using the survey, of course, to identify different ways to overcome some of these challenges and to bring this bar back down to closer to the 0 to effective implementation. And the next step is then to incorporate this into some of the modeling and to inform the modeling and give us more sort of pinpointed, finer grained policy and institutional recommendations that will help move forward some of these solutions. So let me conclude with some of our key messages. So there's a growing interest in co-benefits and the climate, air, pollution, health nexus. There's also a realization of the transnet boundary nature of these problems and the interactions between different air pollutants and different greenhouse gases. That interest has sparked work on solutions. But in order to actually realize the potential of these solutions, we need to strengthen the interface between research, policy, and action. And then this brings us to this feasibility issue. And really, I think the key next step forward is more systematic feasibility assessments of some of the solutions and bringing that into our modeling. And that will help us pinpoint different interventions that can help overcome different barriers and deliver benefits for the climate, air quality, and health. Thank you so much.